Hello, I'm Berrien Morre, Dean of the College of Atmospheric and Geographic Sciences, Director of the National Weather Center, and Vice President for Weather and Climate Programs here at OU. One thing that I want you to keep in mind as we go through this class together is there are certain things that we know about the carbon cycle and about climate that we know absolutely for certain. Carbon dioxide is a greenhouse gas, so is methane, so is water vapor for that matter. And we've known that for a long time, more than a century. I mean, the planet would work if these were not greenhouse gases. And so it's a fundamental aspect of the way the Earth works, and there's no debate about that. Secondly, there is no debate about the fact that carbon dioxide is increasing the atmosphere. It's increased by more than 40%. Methane is more than tripled since the pre-industrial times. There is no debate that CO2 has not increased significantly in the atmosphere from 280 parts per million to around 400 right now. And there's no debate about the fact that the primary reason that carbon dioxide has increased in the atmosphere is the burning of fossil fuels. And we can get at that problem in a whole variety of ways. One way is that when you burn fossil fuels, you're burning old carbon. So the CO2 that you put into the atmosphere in the act of burning fossil fuels doesn't have any carbon-14, the isotope. And so you could actually see a dilution of the atmospheric concentration of C14. Now that's complicated by when weapons were being tested and so forth, nuclear weapons. But it's something that we know very well. There's no real scientific debate about the fact that carbon dioxide and methane are increasing the atmosphere, the concentrations are increasing the atmosphere because of human activity. There's nothing bad about that, it's just a fact. Now, what do we think we know? Well, we think that this is going to lead to climate change. Now we're starting to get into where there is debate, and there's legitimate debate. How significant will be the climate change? How will it impact the water cycle, temperature, seasons, severe weather? Well, some of this we know better than other parts. I think there's pretty good evidence that we will see a continuation of warming. How is that going to affect the water cycle? It's going to evaporate more water, that's pretty obvious, and therefore you got to rain more. Well, what will the distribution of that look like? We're not so sure about that. How about tornadic activity? That's something we don't know. Hurricanes, some evidence of intensification, but still that's shaky. So there are a number of things that we think we know, and then aspects of that we're not so sure. Well, what do we really not know? Number one, it's the $64,000 question or the $64 question, or however you want to call it. The thing we don't know is how do we swap out the energy system of the planet that is dependent upon fossil fuel primarily and swap in one that does not depend on fossil fuel. How do you pull that off? What would it look like? What would be the policies that you would implement to bring about what would be the pluses and the minuses? Who would be the winners and the losers? How would you compensate the losers so that their risk was not so great? That's a really hard problem. That's something that we do not know. What about geoengineering? Should we go out and try to fix this problem? Should we put a sunshade over the planet? What would be the impact of that? Oh, we really don't know how that would work. So there's a lot of things that we do not know. And we have to be clear about what we know for sure, what we think we know, and the gradations of that, and what we have to admit that we do not know. And so I hope at the end of this class that you will have a much greater insight into what we know, what we think we know, and what we do not know.